Hello students, welcome to the KSMP Academy. In this video, we are going to discuss the dimensions of the physical quantity. So as we know now that quantities can be expressed through physical quantities and that is we say derived units. So derived units are expressed in terms of fundamental quantities. So quantities may be having simple 2-3 units, that is maybe mass into time or kg into time, or maybe the complex one. So derived units are the combinations of the 7 fundamental units as we have seen in the previous video. Now these base quantities are expressed in this bracket, that is this bracket. For example, in mechanics we write length as L, mass as m and time as t. So what are the dimensions? The dimensions of a quantity are basically the powers or exponent to which the base quantity are raised. For example, you look at this one. This is ml t minus 2. So here we can write in this way also ml t minus 2. So here these three quantities, that is 1, 1 and minus 2, these are the powers. So these are known as the dimensions of that given quantity. So we will see other examples in the coming slides to understand in detail or in a better way. So first we have to see the dimensional formula. So what we are looking at here is this formula. As you can see, a formula has been written, that is m to the power a, l to the power b and t to the power c. So a dimensional formula is the expression which shows that how and which of the base quantities represent the dimensions of the given physical quantity. So this we say is a dimensional formula of the given quantity, and this dimensional formula we can find with the help of the equations given for the physical quantity. That is, if we know the equation of the quantity or the relation between the fundamental units which are expressing a derived unit, then we can find the dimensional formula. That is basic example we can have a look. That is for a speed. The speed we have distance upon time. So it is L and it is T. So this is giving us the formula as LT minus 1, or we can represent as M0 L1 T minus 2. So this is the dimensional formula of the speed. So we are having the knowledge for the physical relation or the equation of the speed, and based on that we can find the dimensional formula of the given quantity. Examples, let's have a look. For example, acceleration we have discussed earlier also. This is what? This is change in velocity per unit time. So for velocity we have L upon t as we know, and for time it is t. So overall this is LT minus 2. So we represent the formula as MLT minus 2, or simply sometimes we can write as LT minus 2. So it is understood that M is having 0 power. So that this is also the way to represent. Similarly, you see area. So area is L into B. So which is what? Which is L into L or L square, or this is the dimensional formula, or simply L square that we can write. You see density is mass upon volume. So it is mass, this is volume. So volume is L cube, mass is M. So it is giving us ml cube, and of course the power of T is 0. So it is the dimensional formula of density. Similarly, power is work upon time. So for work we have this relation. This you can also derive if you don't remember, and T for time, so which is giving us the formula as ml2 t minus 3. So that is, we have to simplify. If you look at from this, then we are obtaining this one. So here we are having m to the power 1 L square and giving t minus 2 here and t here. So it is giving t minus cube, t to the power minus 3. So that's how we can write the dimensional formula of the given physical quantity from their equation or the relation between the fundamental units. that can be written. So this is the way how to express the dimensional formula of the given physical quantities. Now here are the some dimensional formula of given quantities, as you can have a look in the table. So you see, for example, we have force. So for force we have this formula, mLT minus 2. For pressure, ml minus 1, T minus 2. So for some of the units we should remember work energy and heat, these are expressed as mLT minus 2. We can write m to the power 1 like we are writing, or simply you can write like ml2 T minus 2. That is also the way to write. Similarly, you see here for power, this is ml2 T minus 3. For linear momentum, mlt minus 1. For surface tension, for electric current, for potential, for resistance. And now here the new thing in these two quantities is A. So here A is what? A is the current here, the unit of the current, ampere. So current is expressed as ampere, so that's why here we are having A. Similarly, in the temperature we have K. So K is the unit of temperature. So in the dimensional equation we are using K, or here simply you can write as K. So that means all others are 0, only K is having some power, all other dimensions are 0. For Faraday constant, as you can have a look here, we are having m0, l0, T, A1 and mole. Mole is also coming here, that is quantity of the matter in the Faraday constant. So this is the way, or simply you can write as Ta mole minus 1. That is also the dimensional formula. Magnetic permeability, electric flux, magnetic intensity, as we can have a look here, and electric field intensity. So these are the dimensional formulae of some of the physical quantities. So some of them we should remember, otherwise we can derive them from the equations of the given quantities. Now use of these dimensions we will see to check the dimensional consistency of the given equations. That is how to check. So this knowledge we can use to find the correctness of the equation, and according to this the magnitude of the physical quantities may be added or subtracted only if they have same dimensions, only when they have same dimensions. So that means any of the physical quantity, according to this principle, you can add or subtract only when you are having the same dimensions of these quantities. This is known as principle of homogeneity of dimensions. Now let us check here using this principle. One of the equation is given here. Now what is x? X is the distance. It is distance. x0 is the initial distance. That is also distance. v0 is the initial velocity and t is time. v0 is the initial velocity and t is time in this equation, and a is acceleration. A is acceleration. So as per this principle, all the terms should have the same dimension, and we know that x is the displacement or distance, so its dimensions are, dimensional formula is L only. For x0 also L, the same value it is having, x and x0. Let us have a look for the v0t. So v0 dimensional formula is Lt minus 1, it is velocity, that is meter per second, Lt minus 1, and t is t. So therefore overall dimension is L, again which is same to x and x0. Similarly for the term half at square. So half is the constant, so no dimension. Acceleration